Howdy folks, this is Hal, your friendly geology instructor. This video is basically just about obsidian. What the heck is obsidian? It's gorgeous. I mean, everybody loves it. They think it's super cool, and it is. It's incredibly useful. You can make a sharper blade out of this than you can in any other way. So surgeons doing eye surgery use obsidian scalpels. So just fun fact there. But let's talk about what the heck it actually is. So basically, number one is you need a really high silica lava, so rhyolitic. And the reason that the high silica is so important, basically, as it's cooling, the atoms are scrambling and trying to arrange themselves into a crystal lattice. Let me show you an example of that. So, crystal lattice means that they're organized. This is what a normal rock looks like. But with obsidian, because it's so high silica, basically the silica prevents the organization, and by the time that it cools, the molecules haven't had a chance to arrange themselves into anything resembling an organized crystal lattice. So basically it's so sticky, it's so viscous, it's so hard for the atoms to literally move around that they never get organized. And they stay disorganized, and that's what we call glass. It's essentially an amorphous solid. It's a solid with no crystalline substance structure. That's obsidian in a nutshell. It's volcanic glass because it's so high silica. But as you guys are going to see here at the Big Obsidian Flow, it has a spectacular variety of colors and shapes and textures. So let's talk about that. What we think of as obsidian, it's better thought of as degassed volcanic glass. Degassed, all the gas has left. It's volcanic glass with no gas. Pumice is just the opposite, or it's just the same. It's volcanic glass, but it's super frothy. All the gas is still stuck inside. And when pumice appears white to our eyes, it's because the gas bubbles are super small and the light gets reflected in such a way that it looks light colored. What we'll see here is that pumice can also be dark looking. All it means to be pumice is that it's mostly air. So this dark pumice is identical to the obsidian. The only difference is it's got big gas bubbles in it. So let's see what that looks like. Actually, before we see what that looks like in real life, the reason that we get the dark color, parts per million, tiny concentrations of magnesium. Is that what it says? Magnetite. Magnetite, which is an iron oxide, give it the color. Those tiny little molecules of magnetite are spread out throughout the volcanic glass and make it look dark. Okay, let's see an example of how obsidian and pumice are really just the same thing. The only difference is the amount of gas. Okay, so anyone looks at that, they're like, ooh, obsidian, it's shiny, it's smooth, it's sharp. But then look at the side over here. What you'll see is alternating layers of lighter colored gassy meaning vesicular stuff, alternating with layers of that liquidy obsidian. And you can really get a sense that the obsidian is just where we don't have the gas. Right in between, you see lots of gas vesicles. That's what we're going to call pumice. Yeah, maybe let's take a look here as well, just to kind of reinforce that point. So here's black obsidian. Here's black pumice, where there's more holes. And then right around here, the holes are smaller, and the color looks lighter. It looks grayish. So that's obsidian. Pretty amazing substance.